In this video, I will explore field-based virtual screening with Blaze Demo Server, which is free for use. The Blaze Virtual Screening Experiment is a three-dimensional virtual screen in which we use the field point pattern as our query seed. The query molecule should be in a 3D conformation, a bioactive mode, whether that 3D mode was determined crystallographically or through pharmacophore templating. The query seed, the 3D field point pattern, is used to query the Blaze databases, which consist of millions of molecules with up to 100 conformations of each molecule. The search can be quick, thorough, or exhaustive. Results are reviewed in their 3D orientations relative to the query, and it is expected that compounds with similar field point patterns will be found, regardless of their structural similarity to the seed molecule. The Blaze Virtual Screening Demo Server has proved popular since its launch, and we presently include 3 collections of chemical compounds. These collections provide lead-like compounds for drug, agrochemical, and flavor and fragrance discovery, and are suitable for the evaluation of Blaze in these areas. These collections are open to all registered Blaze demo users, whether accessed through a web page, KNIME, or using Forge, Torch, or Torchlight. Blaze can be configured to run command line or may be run through the convenient web interface. The command line interface can be wrapped with KNIME or Pipeline Pilot or other in-house routing scripts. The Blaze search progresses as a multi-tiered approach with each subsequent step of increasing refinement. The first pass is a coarse comparison of field fingerprints, which quickly eliminates poor matches. It runs on 100% of the compounds in the selected Blaze databases. The next pass is our initial 3D ligand alignment, which is a clique-based alignment. This protocol is run on 50 to 75% of the top hits from the field print pass. Finally, the top 5 to 10% of the clique search hits are subjected to full ligand alignment with the simplex alignment. The ligand alignment algorithm in Blaze is the same as that in Forge, however, there have been some shortcuts included to improve speed. Blaze, of course, runs on both CPU and GPU clusters. Blaze Demo Server runs on our GPU cluster. I will now set up a Blaze run and examine the results. Once the splash page loads, I see the main Blaze panel. On the left-hand side of the page, there is a gray button bar that helps us navigate the interface. To set up the experiment, I will press New Search. Like all of Cresset's software, Blaze is wizard-driven so that it tells you what you need to do at each step. The first panel asks us to import the query molecule in its bioactive or 3D conformation. I have nevirapine structure saved in SD format, which I extracted from the crystal structure 1VRT. So I will browse and grab that structure file now. I will press Submit. In the next screen, I'm asked to check my query seed molecule and confirm that it is what I want to search on. It also gives us a heavy atom count, there are 20, which I will use to reduce the search space so that the hits are similarly sized to the query. My structure looks correct. I will press Accept and Continue. I will give the search a name, RTI, and assign it to a project, Web Clips. I can fill in some comments, which I like to do to annotate my work, especially when running multiple experiments. Next, I will choose which databases to search. I will search all 16 to 25 heavy atom molecules in the Chembl filtered database, which is about 165,000 structures. In a research scenario, I would be interested in searching millions of compounds. In the Search Refinement section, I will set how our search will progress. There are 3 tiers of searching with increasing levels of refinement. I will look at the top 50% for our clique match, then the top 10% of the best scoring results from the clique match for the simplex match. I also have the option to set how molecules are compared. For example, I can choose 100% shape, which would create an experiment similar to a shape-based rock screen. I will leave this as 50-50 shape fields, as this tends to give the best results. I can choose the similarity metric, Dice, Tanimoto, or Tversky, but I'll stay with dice. I can also include field constraints or constrain on a pharmacophore by atom. For example, if I know that certain field points in the query seed are critical for activity, or that a specific donor or acceptor atom are required, I can set a constraint such that the similarity score will be penalized if that field point or atom doesn't show up in the alignment with any of the library compounds. Finally, I have the option of importing my protein structure if it is available. The protein structure is used simply for volume exclusion. Pressing Submit starts the virtual screen. This run usually takes about 5 minutes without any server load. Since our server load on any given day can be unpredictable, I've chosen to set the experiment running, then talk about what's happening in the background. In the left navigation bar, I can click View Results, where I can choose to look at the results of prior experiments or check on the progress of a current calculation. If I look at the current calculation, I can see how far the calculation has progressed. I will come back to this when the run completes. Blaze comes with complete compound database management facilities, allowing you to create new search libraries and update compounds subject to permission levels. I also have quick access to the Blaze user manual, and server status will show what other jobs are running on the cluster. From View Results, I'll select the present search, then go to the Simplex Results screen and look at our results. From here, I can download some of the top scoring results, or I can do some functional group filtering prior to downloading the 3D overlays with the query seed. In virtual screening, this is the exciting part where we can examine alignment of field points and cherry pick the molecules where the alignments look good and the medicinal chemistry looks promising. When running commercial Blaze in a research setting, if you scroll across the molecules table, there are columns that give you information concerning which compound collection the compound is found in, along with vendor details. What I've shown is Cresset's approach to 3D field and shape-based virtual screening. Cresset's Blaze methodology has been shown to produce chemotype enrichment, with resulting hits having lower molecular weights, making them suitable for hit-to-lead optimization. Blaze can be run on a local cluster that you maintain. However, you may prefer to run Blaze in the cloud on our GPU cluster using our curated databases. In doing this, Cresset provides a secure, private virtual machine to keep your data safe. If you have any questions or would like to consider using Blaze in your research program, please contact support@cresset-group.com.